Hey everyone, welcome to the Slice of Construction podcast. I'm your host, Jared Taylor. Joining me today is the CEO of Concrete.ai, Alex Hall. Alex, how's it going?
Awesome. How are you, Jared?
I'm doing well. All is well. Excited to chat with you here today and dig in. And I'm going to start off with the question I always ask every guest. You're walking down the street, you have a Concrete.ai sweatshirt on. Someone goes, "What does the company do?" What do you tell them?
It's normally a bifurcated conversation. If they know anything about concrete, I get a bit more technical, but at a really high level, we're kind of like, we're trying to be the Tesla of concrete. What we're trying to do is we're trying to find the absolute best way to make this product that's so important to society, not only cheaper, but far better from an environmental impact perspective. And we use that by applying a series of different artificial intelligence models that have been created basically over the course of the last 10 years to really understand the ingredients of concrete and allow producers to optimize the product to get the best possible recipe for the outcome that they're looking for.
Maybe I asked you the wrong question too. Maybe I should have said you have a customized rugby football with the logo on it and you throw it to someone. They say, "What is this?" Uh, by the way, you win right now. Coolest display behind you, one person for when I record one of these episodes. I love it. Love the Patriots helmet too. I'm from New England, so love to see that.
Man, the first football games I ever watched were like effectively going into the millennium, and Brady fan as a result. So that's why it's up there.
Yeah, I even followed Brady to Tampa, right? That's and that was not the only reason, but when I moved down here. But well, Alex, I would love to I would love to dig in a little bit about. Let's kind of start off with concrete optimization. So I would love to hear from you on basically the unique machine learning technology that was developed at UCLA that Concrete.ai utilizes for optimizing concrete applications.
Sure. So kind of maybe like a 30-second rundown on this, right? Mm-hmm. So part of the reason we got involved in this is concrete's the second most consumed product on the planet. 30 plus billion tons a year. And I mean, this is a crazy number, but just in the US, we build a Hoover Dam every 3.5 days. That's how much concrete we use. So this thing is absolutely ubiquitous. It's done more for society than anything else. You think cup of coffee in the morning, jump in a swimming pool, drive a car, go in a building. The concrete's a part of the equation somewhere, right? So this is this absolutely ubiquitous product, but at the same time, as important as it is, it has this massive impact from an environmental aspect. 8% of the world's CO2 emissions. So our mission is totally about figuring out how to keep this critical product within society, but at the same time have it less detrimental from an impact perspective. And so we fundamentally come up with two different technologies, the first of which allows us to understand the different raw materials, the combination of raw materials, and then what that allows us then to predict how these things are going to perform. So different combinations are going to give you a different outcome. And provided we have enough data around the physical chemical properties of these things, as well as test results, we can predict what these combinations are going to do. You basically flip that on its head and say, okay, these are the characteristics I'm looking for. These are the constraints I have. And then you let the generative artificial intelligence figure out what the optimal arrangement of the raw materials is and proportions to give you a concrete that is going to have those characteristics. So that's exactly what optimization is. It's figuring out what you're looking for from a performance characteristics perspective, understanding exactly what you have available to you at a specific location, and then arranging that in the optimum combinations from a recipe perspective to give you a product that's going to perform exactly as you want it to.
And when starting out, what were some of the early challenges that you faced, and how did you kind of get past those?
I think it's the same for a lot of different companies in this artificial intelligence sector. It's convincing folks that, look, we're not here to replace people. We're here to supplement what you do. So it's not AI or a human. It's a human and AI, because the AI can only do so much. This is still it's a living product for the first 5.5 hours sometimes if you extend the life of concrete. So you need to understand and bring judgment capabilities that are really more experience based and condition and frankly client based. At the end of the day, people are buying concrete, right? It's not like you're just selling this amorphous mass of a product and it's going to be the same everywhere. Different trade partners have got different requirements in terms of their concrete requirements, and this is something really important that the human being brings to the table. So the product's actually, we ended up changing the name of the product to Concrete Copilot because that's the name of the software. It kind of operates in the background while the human being, typically a quality control person, gets to understand, really what the most optimal solution looks like, but then can also turn around and say, well, hell, I know these guys are looking for a set time of 5.5 hours. They can't wait for 6.5. I'm going to have to make some kind of adjustment on the, cement to cement replacement ratio. I can't have too much flash. Maybe 30% replacement is too much. I'm going to bring that down to 25. And they get the option to actually go in and do the tweaking on the basis of their experience, of their understanding of what the client's going to look for.
And I read somewhere, Alex, that, you have this very ambitious goal of preventing 500 million tons of carbon dioxide from entering the atmosphere.
Annually.
How do you measure and ensure that impact?
So, I mean, this is really based on what we've gone through during our pilot phases. So when we first decided to take this commercial, one thing we realized is that we were going to have to fund the deployment of the technology. And by that, I mean, when we did trials with clients and some pretty big concrete producers throughout the US, we were going to have to fund it to effectively prove that this technology worked. And between the first 3 deployments, what we were able to see was we weren't even looking at CO2 optimization. If we were just looking at a cost optimization, which is frankly, everything to do with the cost of cement. When you look at concrete, the raw materials, cement, depending on the strength of the concrete, is anywhere from 40 to sometimes close to 60% of the cost, right? So if we average it around 45, 50%, cement is that much of the cost of concrete. If you can do anything on the cost side, reduce the cost, the other reality is you're going to have a massive impact on the cement side of things. And also on the CO2 side of things. Cement on its own is roughly 95% of the total global warming potential of ready-mix. And so, reducing the cement quantity is going to have a massive impact on both sides of the fence. So the calculation was pretty straightforward. A typical, 5% saving was also yielding an average of between 17 and 18% of just pure CO2 reduction. And that was without really trying to optimize on the carbon reduction side of things. So, where this ambition is coming from is we think that it's realistically achievable to have a combination of carbon and cost optimized mixes that will get you realistically around that 20% number. And then if you have a look at total annual global cement production is almost 4 billion tons per annum. Our ambition is saying, right, if we get to that 16, 17% number, that's roughly 500 million tons. And the deployment of this technology, whether it's us or other folks that are doing it, but using this technology just to be smarter and more efficient in terms of concrete design and later on the production will ultimately yield that 500 million ton goal on an annual basis. And we think that's pretty significant.
Absolutely. And I'm sure that's one of the things that continues to drive you. What else drives you with this business? What excites you about what you're building?
Well, look, personally, I've been in concrete 25 years. I'm kind of a concrete nerd. Everyone loves concrete to some extent. And I genuinely believe that this product is amazing in the global context, just in terms of what it does. Recently had the opportunity to go into India, and we've started with our first pilot project there. And if you really want to think about impact and the opportunity we have, it's like when you go to a country like India and you have this appreciation that we're working with one company currently that produces 50 million tons more cement that we consume than in the entire US on an annual basis. And so, seeing a country that is very clearly having the benefits of democracy and capitalistic elements happening within the country and massively accelerating out of from a GDP per capita perspective, really increasing, seeing the amount of concrete increasing in terms of the volume per capita that's going up, and also understanding what we can help these folks do, not only in making their product more accessible and quicker to market, more impact from an infrastructure perspective, but at the same time having an impact on the environment. This is the kind of thing that really keeps me up at night and frankly keeps me super excited. It's as important as the US is, because we got to develop the technology and we got to lead for by example, be a world leader and showing folks how we can do things. What's really exciting is being able to see this stuff, being able to be transferred, go into new countries, and seeing how excited people are about deploying this kind of technology.
Absolutely. I guess can we go a little bit into, Alex, around the AI component? Like, at what point did you notice the impact that AI could have in this space? And I guess part two to that question, you've mentioned it a little bit, but maybe you can go deeper into it in terms of why is it so important to be able to create these optimal mix designs. So kind of two parts. First, AI's role, and then I'm sure it kind of ties in with that piece.
Came into this environment a little bit with a different agenda. At the time, I was working for a cement company, and cement companies have been totally aware of the CO2 reality that they're going to be facing since probably the late 90s. In all reality, I'd been with that company for like 16 years at that stage, and found out about this product that was being developed at UCLA, where there was a new type of binder that was being created, basically introduced CO2 into the binder within a block environment, and this product would actually ingest the CO2, help the CO2 would actually help the mineralization. And unlike a lot of the other companies that have CO2 associated with concrete, this is waste CO2. This is not CO2 you're going to manufacture somewhere, bring it off site, and then pump it into your ready mix plant. This is actual waste CO2 generated at the location, put into the block, and pretty significant yield, not only in terms of improved mineralization, so reduction in cement going in, but ultimately waste CO2 being utilized in this product. And I got super excited about it. Wanted this company to invest. They decided not to. I got the opportunity to join in. And then got really friendly with the guy that founded that organization, and got started talking about it. And one of his first questions to me was, what's the opportunity, do you think, for utilizing artificial intelligence within the concrete environment? Like, I had a different hat on at the time. I'm going, well, hang on a second. If there's a way to find the right combination of materials and look upstream into our business, because we also had aggregate businesses, why couldn't we find a way to really manage cash as best as possible, and just what's the opportunity? And that was the rabbit hole. That's how it all started. I provided them with some data from that company. Obviously got all the permissions that we needed to go, and the guys started working on it. And what became really clear to us is that we thought our quality control people, a big part of their job was focusing on design and design optimization, but it really wasn't. The guys were frankly doing another job, and that is firefighting, keeping clients happy, making sure things were working on a day-to-day basis, and optimization really actually wasn't that much of a consideration. So it became clear to me that this was a huge opportunity. Fast forward about 4 or 5 years later, I'd left the company. I was working for a construction company called Suffolk at the time. The owner of Suffolk actually loved where we were going. He invested in this consortium at UCLA called Transcend. We still kept on working on this stuff, and it became really clear to me that this is a product. Like, if we can find a way to really rethink about how we go around concrete design and concrete optimization and move away from this typically experimental process, where it's kind of more trial and error in historically, where you have existing mix designs, you kind of know how they perform, and you replicate that design to try and get close to something else, but you're never really following up with like heavy math, like deep modeling to multiple dimensions, and then thinking about what those different impacts of the different raw materials and their physical and chemical properties are going to have. And that's kind of the door that AI unlocks. Right? It allows you to start modeling into multiple dimensions, multiple different characteristics, but then not just in the physical and chemical properties. Think about all the different performance characteristics that you're looking at as well. And yeah, that really got me excited. The guys at UCLA got a pretty big grant from the Federal Highways Association, got access to tons more data, and then it became pretty evident that now's the time to pull the trigger. We waited until 2021 when the guys at UCLA got sign off from Federal Highways Association, basically agreement that this technology was now at a readiness level and we're ready to go and do some commercial trials. And we went out, raised some capital, and that's exactly what we did. So that was the first part. So the second part.
Second part. No, that was great response and great story. Thank you for sharing. Second part was around, and you've hit upon some of this already, but why is it so important to be able to create those optimal mix designs? Like, let's get really, I guess, high level and then even deeper.
So there's really two answers to that question. I think the first one, my experience in the ready mix business, ready mix is like crazy. Like if you think about construction, how early you get up to go and get it, you go, the first guy outside, the site manager's going to get there and he's going to have someone unlock the gate and stuff. It's probably not them. It's probably going to be a super. But I mean, whatever, that's 5 o'clock in the morning. Well, the ready mix guys have been at the plant since 3, right? They're getting everything set up. They're getting all their moistures done. It's a hectic business in terms of getting ready for the day. It's a product with a 3-hour shelf life. Effectively, you really got to be on top of the schedule. And, it's a super low margin for such a crazy business. If you have a look at the ready mix businesses in the US, the typical margin is somewhere between 7 and 10% at an EBITDA level. The US is also super, I'd say, focused so much on the customer and quality side of things. So that unlike Europe and many other parts of the world, most places the producer actually owns the ready mix fleet as well. So the trucks belong to the producer. So that distribution element actually brings a pretty significant capital cost. So when you really get down to brass tacks, this is a business where it's like, EBIT margins in the mid single digits. And, that's not a hell of a lot of reward for the amount of effort you're putting into it. So, my thing around this is raw materials are 60, 65%, well, 55 to 65% of the cost, depending on the product that you're making. If there's an opportunity to optimize that and give the producer back a 5% saving, well, hell, that's a massive improvement in your net EBIT margin. That's going to be pretty significant. Let's really focus on that as an economic incentive and get people to think about it that way. Then the other reality is that I want this product to be around for a long time. The benefits of society is crazy, but how do we make it less impactful in the environment? And so at the same time, let's think about using the same kind of technology and really deploying it in such a way that we can have the lowest possible embodied carbon associated with this product and make sure that concrete is here for the future. Same time, we supply agnostic. I don't care if it's brand X cement, this fly ash, whatever aggregate, right? I want to find what's best for the producer. And so we also see ourselves as being a vehicle to a whole lot of these new cement substitute products that are coming on the market. And ultimately, what we want to be able to do to them is demonstrate to people how we can take these products and, in some cases, use mix designs, make them as cost effective as possible. So, we don't want to see these businesses be subsidized by the federal government for the rest of the time, because that just doesn't make sense from an economic perspective. We want to find a way to make these products as effective as possible and get them deployed.
I love it. Alex, I want to thank you so much for joining us here today and telling the story. And you're a great storyteller, by the way. That's what we want on this show. We want
Tell my wife that. Tell my wife that.
Well, I don't touch that. That's I don't want to tell her. And but
Yeah,
I
she wouldn't listen.
if you want me to, I will. That it's settled.
I'll give it a go. Okay.
Alex, look forward to future conversations. Let's definitely stay in touch. Wishing you the best of luck, and we will go from there. We'll talk soon.
No, I appreciate it. It's a great format as well. Thanks so much for your time.